Welcome to SciSpectrum Lab Essentials, your source for equipment, instrument, and consumables.
All right, today we're going to deconstruct a piece of lab equipment that you've probably seen 100 times, but maybe never really thought twice about. I'm talking about the laboratory stirrer.
I mean, really think about it for a second. How do you make absolutely sure that every single drop of a life-saving vaccine has the exact same formula, or that a face cream has that perfect silky smooth feel? What's the secret sauce for creating a totally new material in a lab?
Well, the answer, pretty much every time, comes down to this one powerful, precise tool. It's kind of the unsung hero of the lab, right? It's what guarantees consistency, reliability, and honestly, the success of countless experiments and products we use every day.
Okay, so here's the game plan. We're going to start with the absolute basics, the physics of what a good mix even is. Then we'll get to know the different families of stirrers, the ones you see every day, the heavy lifters, and the real specialists. And to wrap it all up, we'll go through a super simple guide on how to pick the perfect tool for whatever job you've got.
So, first things first. Before we can even start talking about the machines themselves, we really need to get a handle on two key ideas that define, well, every single mixing job out there.
The first concept is viscosity. It's basically just a fancy word for a fluid's thickness. You know, its resistance to being moved around. Stirring water? Super easy. That's low viscosity. Now, trying to stir a jar of cold honey? That's a workout, and that's high viscosity. This one thing is probably the most important property you need to keep in mind.
And to fight back against that viscosity, you need something called torque. Torque is just the raw twisting power of the stirrer's motor. I love this bicycle gear analogy, it's perfect. You use a low gear to get that high torque you need to climb a steep hill, right? Well, it's the exact same idea here. You need a high torque stirrer for a high viscosity fluid. Simple as that.
Okay, so with those two ideas locked in, let's meet our first group of stirrers. These are the direct drive models. You can think of them as the everyday workhorses you're going to find in pretty much any lab.
So on the screen here, we've got two fantastic examples. The RQ5 Plus and the RQ100 Plus. Now, at first glance, they look pretty similar, don't they? But trust me, under the hood, they are built for completely different scales of work.
Now, this is where it gets really cool, because the specs here tell the whole story. Look at the capacity. We're jumping from 5 liters to a whopping 100 liters. And check out the motor power. It leaps from 10 watts to 100 watts. So the RQ100 Plus isn't just a little bit bigger. No way. It's a 10-fold power jump designed for massive, way more demanding tasks, even though they're both in that same general-purpose category. But what they have in common is just as important. Both of these are packed with smart tech. They've got a microprocessor that keeps the speed perfectly constant, which is absolutely crucial for getting results you can reproduce. They have safety features to stop the motor from burning out, and they even remember your last settings. See, this isn't just about spinning a stick in a beaker, it's precision-controlled motion.
So what happens when you're dealing with something really tough, like paints or thick creams or even polymers? For that, you got to bring in the heavy machinery. So let's meet the high-torque geared stirrers.
This right here is a geared stirrer. You can almost feel the power just by looking at it, can't you? That big motor housing, that's where the gearbox lives, and that's the secret to its strength. It basically trades top-end speed for raw, twisting force. In other words, it's got massive torque.
And this just nails their whole purpose. The source material says it perfectly. These are for low-speed and high-torque jobs. They are purpose-built to handle those thick, gooey, viscous materials that would make a standard direct drive stirrer just give up in seconds.
So, what makes them so tough? Well, for starters, they use powerful PMDC motors. That's permanent magnet DC motors, which are built for non-stop heavy-duty work. They also have some really clever design features like a hollow shaft. That lets you adjust the paddle height without having to move the whole heavy motor. And for really sensitive environments, you can get brushless motors that won't create any sparks. Pretty smart.
All right, now we're going to shift from brute force to high-speed finesse. Because sometimes your goal isn't just to mix things together, but to completely transform them into something totally new. Welcome to the world of homogenizers and emulsifiers.
Homogenization is such a cool process. We're not just talking about shaking up oil and water so they mix for a minute. No, this is about using intense mechanical force to smash particles down so fine that they form a totally stable, uniform mixture. That's called an emulsion that just won't separate over time. Think about mayonnaise or a really good salad dressing. And this is the tool that does it. A homogenizer just looks different from a regular stirrer, doesn't it? See that specialized head at the bottom? That's where all the magic happens. It's not just a propeller, it's a super precisely engineered rotor-stator system.
So here's the breakdown of how it works. The inner part, that's the rotor. It spins at insane speeds. We're talking thousands of RPM. This creates a powerful vacuum that sucks the fluid up into the head and then forces it out through tiny little slots in the outer part, the stator. This whole action creates an incredibly intense shearing force that literally rips the particles apart, and that's how you get that perfectly stable emulsion.
Okay, deep breath. We've met the whole family now, right? The workhorses, the powerlifters, and the specialists. Now we get to the most important part. How do you take all this info and actually choose the right tool for the job? This slide is great because it just boils it all down. If you're working with thin, low-viscosity stuff like water, a direct drive stirrer is your best friend. If you've got thick, high-viscosity materials like paint or heavy lubricants that need serious muscle, you need a geared stirrer. And if you're trying to create those super stable emulsions like a cosmetic cream, nothing's going to beat a homogenizer.
And to get even more specific, you should always ask yourself these 4 questions. Number 1, how much stuff are you mixing? 5 liters or 100? Number 2, what's the viscosity? Are we talking honey or water? 3, what kind of speed do you need? And last but not least, do you need a digital display for process validation? To prove you're following a procedure exactly the same way every single time.
And look, if you only remember one thing from all of this, make it this quote. The source material puts it right there in black and white. The very first thing you need to figure out is your batch size, your volume. That one answer is going to immediately narrow down your choices and get you going in the right direction.
So at the end of the day, picking the right stirrer is about so much more than just, spinning a liquid. It's actually fundamental to good science. The right tool is what makes sure your results are consistent, that they're reliable, and that you can repeat them. And that's true whether you're developing a new drug or just a better can of paint.